There's an approach gaining traction right now that basically promises to solve everything we just talked about in the last two episodes. The pitch goes like this. Put an LLM in front of the agent, have it analyze what the agent is about to do, infer what permissions it needs, and then generate a tightly scoped, short-lived identity for exactly that action. Ephemeral credentials, least privilege, all derived automatically by AI in real time. So it's basically the answer to episode 11 and episode 12 wrapped into one. And I have to say that on the slide, it looks amazing. The problem is the inference step. You're asking a language model to look at an agent's intended action and figure out what permissions that action requires. And that's a genuinely hard problem even before you get to the security implications. Take a concrete example. An agent gets a prompt that says, set up a staging environment in Azure. To issue the right scope credentials, the monitoring LLM needs to figure out which Azure permissions that task requires. Azure has thousands of granular permissions across compute, networking, storage, identity, and monitoring services. The exact set depends on the specific architecture, the existing resource groups, the naming convention, and the policies already in place. And so ask 5 Azure engineers what permissions are needed, and you'll get 5 different answers. And now we're asking an LLM to get it right, every time, automatically. There are basically 3 ways this goes wrong. Either the LLM overscopes, giving the agent more permissions than it needs, and then you've essentially defeated the entire purpose of least privilege, or the LLM underscopes, and then the agent just cannot complete the task, and then the user or the system escalates to broader permissions anyway, which usually means something even less controlled than what you started with. Lastly, the LLM might get it roughly right, but the agent's intent was already corrupted by prompt injection. So you've just issued perfectly scoped credentials for an attacker's instructions. And so, as you can see, every path here is a dead end. And that's assuming a relatively straightforward task. Real-world agent workflows chain multiple actions across multiple services, and the permissions graph gets exponentially more complex at each step. Now, this specific approach is actually an instance of a broader idea that keeps showing up. Using AI to govern AI. Whether it's inferring permissions, monitoring agent behavior at the reasoning layer, or writing better guardrail prompts to prevent misuse. The common thread is layering probabilistic judgment on top of probabilistic judgment and hoping the outer layer catches what the inner layer gets wrong. The monitoring AI has the same fundamental problem as the agent it's watching. It's non-deterministic, it can be influenced by adversarial inputs, and it cannot reliably tell legitimate intent from manipulated intent, because a prompt-injected agent isn't confused. From the model's perspective, it's doing exactly what it was told. The instructions were just successfully replaced. Monitoring agent behavior does have real value, but it needs to happen at the execution layer. You observe what agents actually do, not what they meant to do. That's a fundamentally different approach from having one language model try to read another model's mind. That distinction matters because it points to where this whole module has been heading. Episode 11 showed that making credentials short-lived does not address agent compromise during a valid session. Episode 12 showed that tight scoping does not prevent misuse within authorized scope. And now we've seen that trying to automate both with AI introduces its own layer of uncertainty on top of the problem it's trying to solve. The controls that actually work for agents operate at the execution and identity layer and not at the reasoning layer. And that's exactly where we're going next.